In this video, we are going to see solution of partial differential equation. A solution or integral of a partial differential equation is a relation between dependent and independent variables which satisfies the partial differential equation. There are types of solution or integral. First is complete integral. Complete integral is the solution contains as many arbitrary constants as there are independent variables. Next is particular integral. Particular integral is a solution giving particular values to the arbitrary constants. Next is the singular integral, where it is a solution which doesn't contain arbitrary constants or arbitrary functions. Next is the general integral. General integral is the solution which contains as many arbitrary functions as the order of the equation is called the general integral. So now we are going to find the solution for the first order partial differential equation of standard types. There are solving first order partial differential equation of standard types. Here there are 4 standard types. This is standard type 1, where the equation is of the form f of p comma q is equal to 0. So first problem is solve pq plus p plus q is equal to 0 is the question. So here we are going to solve this. That is, we are going to find out the solution. So let us consider the solution to be z is equal to ax plus by plus c. So here, if we differentiate this partially with respect to x, we'll be getting dou z by dou x is equal to a. Or otherwise, using the usual notation, dou z by dou x can be replaced as p, which is equal to a. Similarly, differentiating with respect to y, dou z by dou y is equal to b, which implies q is equal to b. Now let us mark this equation as 1 and this equation as 2. Now substituting in equation 1, we get ab plus a plus b is equal to 0. So from this equation, we can either consider a in terms of b or b in terms of a. So here let us consider b as a function of a. So here taking b common, it gives you a plus 1 is equal to minus a, or otherwise b is equal to minus a divided by a plus 1. Okay, so now we can substitute b as minus a by a plus 1 in equation 2. So while substituting in equation 2, z is equal to ax and b can be substituted as a divided by a plus 1 into y plus c. Okay, so this is called as complete integral. Okay, because this is a solution which contains 2 arbitrary constants a as well as c, because this is the equation involving 2 independent variable x and y. So we can call this to be the complete integral. Next, to find out the singular integral. Usually we will be finding complete integral, singular integral and general integral. So this is being the complete integral, that is z is equal to ax minus a divided by a plus 1 into y plus c, which is the complete integral. Okay, now to find the singular integral, we have to differentiate partially with respect to the 2 arbitrary constants a as well as c to get the singular integral. So first let us differentiate partially with respect to c first. So left side there is no c, so that gives you 0, and in the right side, first term doesn't contain c, second term doesn't contain c, only in the third term we are having c. Differentiating that, it will give you 1. But this is an absurd result, which means that there exists no singular integral. So we can conclude that there exists no singular integral. Next is to find the general integral. To find the general integral, what we have to do here is put the arbitrary constant c as function of another arbitrary constant a. because in this complete integral we are having two arbitrary constants. One is a, another is c. So one should be replaced in terms of other. So let us substitute c is equal to f of a in the complete integral. So that gives you z equal to ax minus a divided by a plus 1 into y plus f of a. So how to obtain the general integral is, first we have to differentiate this partially with respect to a, that is the only constant available here. So this gives you 0, which is equal to, here it will become x. Similarly here you have to use u by v formula. So this gives you a plus 1 whole square, and in the numerator a plus 1 into 1 plus a into 1 into y, plus this becomes f dash of a. So from these two equations, this is, let it be 3, let it be 4. So now eliminating a from equation 3 and 4, we obtain the general integral. Now moving to the next question, p square plus q square is equal to 4pq. So again here let us consider the solution. Z equal to ax plus by plus c. So as usual here we can substitute p is equal to a and q is equal to b. So if it is a problem under standard type 1, directly we can substitute p is equal to a and q is equal to b in the given problem, that is equation 1. So now putting in equation 1, that gives you a square plus b square is equal to 4ab, or otherwise we can write it as b square minus 4ab plus a square is equal to 0. So now which is a quadratic equation in B. So while solving this equation using quadratic formula, we can obtain the value of B. So using that formula here, we can substitute 4a plus or minus root of 16a square minus 4a square divided by 2 to a. A is 1 here. That is, it is of the form minus b plus or minus root of b square minus 4ac divided by 2a. So that is the quadratic formula. So using that quadratic formula, we have substituted here so that we can easily obtain the value of b. So while simplifying this, 4a plus or minus 16 minus 4 is nothing but 12. So 12 can be written as 2 root 3a. Okay, a square root of a square is a divided by 2. So simplifying this, 2 get cancelled. So the answer will be 2 plus or minus root 3 into a. So this is the value of b. So how to get the complete integral is, substituting in equation 1, z is equal to ax, b is substituted as 2 plus or minus root 3 into a into y plus c. So in this we are having only two arbitrary constants. So this is called as complete integral. Next again we have to find out the singular integral. So first let me write down what is the complete integral. This is the complete integral. Now to find singular integral, as usual I told you that differentiating partially with respect to c, 0 is equal to 1, which is an absurd result, so that there exists no singular integral. Next, to find the general integral. So to find the general integral, as I said, put c is equal to f of a in the complete integral. So that gives you z is equal to ax plus 2 plus or minus root 3 into a into y plus f of a. So now we have to differentiate with respect to a on both the sides. So 0 is equal to x. Here 2 plus or minus root 3 into y. Here it is f dash of a. So now let it be equation 3 and let it be equation 4. So now eliminating a from equation 3 and 4 will give you the general integral. So that's it for this video. Thank you for watching.